In this video, we'll continue our discussion of 2.3 by working two more examples. There aren't many new ideas here. I just want to make sure I'm working quite a bit so you're not lost. All right, so first things first, they want us to solve this first order linear, find I, which is the interval. It's the solution is defined, and then the transient interrupt thing from last video. Okay, so first thing, I got to put it in standard form. That means dy dx needs to be by itself. So I'm going to divide everything by 3, leaving me with the 4y, and then a 4 over 3. All right, so now that looks like what we've been working. We know mu is equal to e, the integral of px dx. And remember, px is the number, once it's in standard form, it's the number in front of your y. So this is going to be e to the integral of 4 dx, which is just going to be e to the 4x. That's going to happen quite a bit. E is a very powerful function. I could go on a rant, I won't. Okay, so now I'm going to multiply everything by this mu. So e to the 4x times dy over dx plus 4e to the 4x times y equals 4/3 times e to the 4x. All right, the whole purpose of that is now using mu, we actually created a product rule. So we get this. Eventually, you might just stop writing that. It's up to you. I typically don't, when I work these out, like to check or something. All right, I'm gonna write it again, spread this stuff out, and put in my integrals. So integral here, dx, integral here, dx. Those dx's are important. If you haven't taken Calc 3, we could do dy, dz, d mu, d theta. We could do a bunch of different integrals with dx's and different stuff. So you have to put it there. Please do. Okay, so e to the 4x times y equals, okay, and then this is going to be, we could do u sub, but I would really encourage you just to get fast at this. So I know if this, I know the 4/3 stays, and I know that before, like to get to that integral, I'll have to do a chain rule, like derivative. So I write down 1/4 because now if I take the derivative to go back, that 4 is going to come out with the chain rule and it's just going to cancel that fourth. So if you want to take the integral of e to something and there's a number in front of the x, just do 1 over that number and that's your integral. Now don't forget c. All right, so now we're almost there. We got y. How I'm going to get to our final answer is I'm going to multiply by e to the negative 4x on all sides. That will get rid of our left-hand side, making e to the 0. That's 1. But everything else will also get multiplied by that e to the negative 4x. This turns out to be a 1/3. 4's cancel. And then that e to the 4x is going to be canceled by the e to the negative 4x. And then c gets that negative 4x. So there is our solution. Okay. And then I, again, there's nothing keeping me from putting, having a negative infinity to infinity. And then the transient term, transient is c e to the negative 4x because it goes to 0 as x goes to infinity. So there are the three things that they were wanting. All right, we're going to do another example in this video. Doesn't change difficulty too much. There is just some difficult integration in there that I would like to remind you of some skills. All right, same directions. I like to work these when I do first order linear. I feel better when it looks like this because that's the way the book presents us. What they typically look like. And then remember, we have to make sure this is in standard form. So dy dx minus 2y, and then I leave the x stuff or the constants over here. All right. Now, if you take a look at that, it's definitely first order linear, first order, first derivative. Linear, the derivative of y are not being squared or anything weird. All right, so this becomes, oh, we need mu. Let's do that first. Mu is e to the negative integral of 2 dx. That negative comes up with it. So I get neg e to the negative 2x will be my mu. So this is, in the last one I said, hey, I usually skip multiplying it out. So this, I'm going to show you what I mean. I usually just do d dx, and I know this is going to be mu times y every time. And then all I have to do is make sure I multiply that left-hand side by the e. All right, so that's what we get. This integration is the reason I picked this problem. I'm going to show you what is called tabular integration. And your Calc 2 teacher may have shown you some. I know I have colleagues that don't like to show it because it's a trick, um, but it's a fair trick that's used often. So left-hand side just comes straight out. And then the right-hand side, we're going to have to use integration by parts. But here's the deal. If I do integration by parts the way it stands, I think I'm going to have to do it twice. Anytime I have to do it multiple times, what I look for is I'm looking for a vanishing, what's called a vanishing term. And that would be this term right here. Oops, I thought that was a highlighter. This term right here is called vanishing because eventually I'll take derivatives and it'll go away. So I'm always looking for that vanishing function. And then I'm going to go over here and we're going to do what is called tabular. Right. Okay, and then the first one is our plus or minuses. This will be our derivatives, and then the last one will be our integrals. Right? And this always goes plus, minus, plus, minus, plus, minus. And I don't know how far we'll have to go. I'm going to put x squared plus 5 here, because if I just keep taking derivatives, that's what I wanted. I want that column to go to 0. If not, then the tabular thing's not going to work. Okay, so the integral then has to be the e to the negative 2x. And this is why I said just understanding that pattern will help you out. So that's a nasty 2, so I'm going to rewrite it. Right? If I take the derivative of this, that negative 2 is going to come down and cancel the negative 1/2. If I do 1/4 now, I'm just multiplying by another 2. The negative 2 would come down and make a negative 1/2, like the one above. And then our last one here that we need, it's going to be a negative 1/8 e to the negative 2x. That negative 2 would come down, make a positive 1/4 because they're both negative. And then you only have to go to the 0 row. So don't need those. All right. This is how the answer goes. This is why this is pretty neat. I'm going to use a highlighter. Let's see, I think purple. Yeah. So you do these two, these three, and these three. You're multiplying along the highlight, and then you add your terms. So this becomes, I'm going to scoot it over because if not, I think I'll be shoving it over there. We're going to get negative 1/2 times x squared plus 5 e to the negative 2x. Right? Then I'm following the next one. I get minus 2 over 4 is going to be a half x e to the negative 2x. And then our last one is going to end up being a minus, and 2 over 8 is a fourth, and then e to the negative 2x. There we go. So that's what comes out of it. Now I'm going to multiply everything by e to the 2x, and that actually gets rid of all the e's, kind of, thankfully. So I am going to drop my e's. All right. And then all I got to do is simplify. So y equals negative 1/2 x squared minus 5 over 2 minus 1/2 x minus 1/4. And then I can combine like terms. Negative 1/2 x squared minus 1/2 x. And this is going to end up, you can use your calculator if you need, negative 11 over 4. This is a polynomial, so I actually can pick anything I want. As long as I'm not dividing by x above or anywhere, I'm not. And then there are no transient. Remember, transient means that it will go to 0 as x goes to infinity. This polynomial is not going to do that. No polynomial will do that. Okay, so there we go. There is our answer. All right, so I have many more examples. I'm trying to give you everything you need. That way you're not stuck at all. And then you can apply these to more complicated problems.